Okay, let's consider the intermolecular forces that are involved between two molecules and try to think about what that might change in terms of the physical properties of that molecule. Some intermolecular forces are stronger than others. Hydrogen bonds are one of the strongest intermolecular forces. So if you have, as this intermolecular force increases in strength, you'll have a higher melting point. Makes sense. You'll have a higher boiling point. It will take more energy to break those intermolecular forces. Note that I'm not using the word bonds. This is between two molecules. The surface tension will increase, right? And that's why you will see that sort of tension between the molecules, because the stronger it is, the more tension there is holding that together. And the gases don't have any at all, so you have a huge difference at the liquid to gas interface, which shows up as strong surface tension, for example, in water. The viscosity will increase. Things will get thicker. Solubility will increase as they increase in strength. So things like water can be a pretty powerful solvent. The reactivity can increase since you're going to have more opportunity for chemical bonding, for chemical reactions. Density oftentimes can increase. Vapor pressure will decrease since you have a higher boiling point. So the vapor pressure over that liquid will be less. There'll be less gas molecules when you have a stronger, higher boiling point. The heat of phase change should decrease. Fusion, vaporization, and sublimation, I'm not going to comment on that too much. And the enthalpy of solvation, that's the heat that is required during solvation or released, will decrease, and I don't want to comment on those two. These are a little more esoteric, don't play too much of a role until we get into the energy units, so have a look at those units if you want to see more detail. But this is all the things that happen. Most questions revolve around melting point and boiling point, but a lot of things will change as the intermolecular forces increase in strength. Let's make a little note here. For network solid substances like ionic compounds, where there's just this continuous lattice, metals also are network solid substance. The terms intermolecular and intramolecular kind of lose their meaning because that's the only force that's possible in a something like sodium chloride. It's a continuous lattice of dipole, of ionic bonds, and so there's not as many intermolecular forces at play.